So, having finished glycolysis, we're on to the next step of cellular respiration, which is the citric acid cycle, assuming that there's oxygen present. Remember that this is only going to happen if there's oxygen present. But before we can start the citric acid cycle, there's one more step that has to happen, because pyruvate cannot enter the citric acid cycle. It needs to be converted into something else first, which then enters the citric acid cycle. So there's one step first, and then we go to the citric acid cycle. So at the end of glycolysis, we ended up with 2 ATP, 2 NADH, and 2 pyruvate. So we haven't lost any carbons yet. All of our carbons are still accounted for. We started off with 6 carbons in a glucose molecule, and now we have 2 pyruvate molecules, which are still 6 carbons. So we're going to start by looking at our pyruvate when oxygen is available. And the pyruvate goes into the mitochondria. So before this, glycolysis happens in the cytoplasm, but now we're moving into the mitochondria, where we're going to finish the oxidation of glucose, meaning we're going to strip it of its electrons, we're going to reduce other things, oxidize glucose, and get all the energy out of it that we can. So like I said, before we go to the citric acid cycle, there's one more step that must happen, and this is the oxidation of pyruvate. So we start off with our pyruvate, and we're going to change it into something called acetyl-CoA, which stands for acetyl coenzyme A. And this is what takes glycolysis into the citric acid cycle. So this is characterized by a multi-enzyme complex, which means complex, a bunch of things together, made by multiple enzymes, which does 3 reactions in a row. You don't need to know what these 3 steps are, except you should know that oxygen or a carbon dioxide is released in this step, and NADH is released in this step, and we end up with acetyl-CoA. Okay? So this is just for one pyruvate. So we see here 1 pyruvate gives us 2 CO2 or 1 CO2, 1 NADH, and 1 acetyl-CoA. So this happens twice for every glucose molecule, because remember, each glucose molecule gave us 2 pyruvates. So this is going to happen twice, okay? And notice here that now we've lost a carbon. So now we went from 3 carbons to 2 carbons that were still accounted for. This is gone. We already breathed them out. So now we have 2 carbon acetyl-CoA. And this happened twice, remember, because we had 2 pyruvates. So we lost 2 carbons as carbon dioxide. And now, so we started off with 2 pyruvates. And now we lost 2 carbon dioxides, one from each of them. So now we have 2 carbon molecules. So we're at 4 carbons right now. Then we go into the citric acid cycle. So the citric acid cycle happens inside the mitochondria, and the first reactant is acetyl-CoA. So this could be called the citric acid cycle, could be called the Krebs cycle, it could also be called tricarboxylic acid cycle. We're just going to call it citric acid cycle. And this is where we finish breaking down the pyruvate into carbon dioxide. So we're going to be rid of all the carbons by the time we're done with this. And this the cycle is going to keep oxidizing our organic fuel. So we already oxidized glucose to pyruvate. We oxidized pyruvate to acetyl-CoA, and we're just going to keep oxidizing, keep stealing their electrons, because the electrons are going to be carried to the electron transport chain, where we can get so much more ATP out of them via oxidative phosphorylation instead of just substrate level phosphorylation. So each turn of the cycle results in 1 ATP, 3 NADH, and 1 FADH2. FADH2 stands for flavin adenine dinucleotide, which is just another electron carrier, just like NADH, okay? So each turn of the cycle gives us this: 1 ATP, 3 NADH, and 1 FADH2. Except remember, for each glucose, this happens twice, because each glucose gave us 2 pyruvates, which gave us 2 acetyl-CoAs. So we have 2 acetyl-CoAs going into the citric acid cycle, which means overall we're going to get 2 ATP, 6 NADH, and 2 FADH2. So here's our pyruvate. We oxidize it to acetyl-CoA at first, which means we get an NADH and we get a CO2. Okay? Then the acetyl-CoA goes into the citric acid cycle. You don't need to know these steps except for one, and I'll tell you what that is in a minute. You don't need to know these steps except know that it's a cycle. We put in acetyl-CoA, and we lose 2 carbon dioxides. Okay, so we started with 3 carbons up here. We lost one right here. Going into the cycle, we had 2, and now we lose both those 2 in the cycle. Okay, so we're done with carbons. Our carbons are gone. We have harvested all of the energy from the actual glucose molecule that we could, and we've stored it either in ATP or in our electron carriers to get more energy later. Okay, so we get 2 carbon dioxide. This is exhaled as waste, or released from the cell as waste. We get 3 NADH, 1 ATP, 1 FADH2 per each molecule of pyruvate. So for each molecule of pyruvate, we get 1, 2, 3, 4 NADH, 1, 2, 3 carbon dioxides, 1 ATP, and 1 FADH2. And overall, that's doubled because there were 2 pyruvates from each glucose molecule. So overall, we have 1, 2, 3, 4 times 2 NADH, so we get 8 NADH. We get 1, 2, 3 times 2, 6 carbon dioxides per glucose molecule. In this step, we get 2 ATPs overall and 2 FADH2s. Okay, so there's 8 specific steps of the citric acid cycle. You do not need to know them. There's one important thing about the citric acid cycle that you must know, and that is that it is a cycle. So acetyl-CoA goes into the cycle right here. Acetyl-CoA goes in, and it's met by a molecule called oxaloacetate. Okay, and acetyl-CoA binds with, or the acetyl part of it, it binds with oxaloacetate. Then it goes through 7 steps. 1, 2, 3, 4, 5, 6, 7, 8 steps. And now this cycle is complete. We've lost our carbon dioxides, we've gained our 3 NADHs, we've gained our ATP, we've gained our FADH2, but we are left with oxaloacetate, which means it happens again. Okay? So you should know that oxaloacetate starts and ends the citric acid cycle, and that's why it's a cycle. And that's it. That's all you need to know about the citric acid cycle.